Hello, guys. Welcome to our Neurodiversity in Children's Classroom presentation by myself, Sarah, and Chantal. So the first thing we're going to be talking about is neurodiversity and ADHD. So neurodiversity is a term used to describe a brain that works differently from that of a typical brain. So neurodiverse individuals include those with autism, ADHD, and learning disabilities that affect the way that one thinks, learns, and perceives information. ADHD stands for Attention Deficit Hyperactivity Disorder, and children with ADHD have unique strengths and difficulties with specific cognitive skills that interfere with their learning. A child with ADHD shows deficits that affect their executive functions, which consist of three main cognitive components. So we have working memory, inhibitory control, and cognitive flexibility. And we believe that by accommodating the needs of children with ADHD in the classroom, schools can create supportive and appropriate learning environments that foster cognitive growth at their own pace, as these children may require different types of learning strategies to succeed.
We're going to talk about the three types of ADHD. So, number one, we have hyperactive impulsive. So, high activity level is the main problem, and this one is more uncommonly diagnosed. And number two is inattentive. So, an inability to sustain attention is the main issue. And number three is combined. So, presents symptoms from both hyperactive impulsive and inattentive ADHD.
So in this project, we are challenging Piaget. So his theory of cognitive development. Piaget believed that cognitive development occurs in discrete stages which are achieved at a certain age. However, this theory is limited as the concept of defined cognitive developmental milestones does not account for children with ADHD. We found a study by Shu and Douglas, and they found that children with ADHD develop 3 to 4 years later than neurotypical peers in terms of executive functioning in the frontal lobe region. So this showcases how variable these stages are achieved and that they do not apply to neurodiverse children's cognitive development. It is important to challenge these theories in order to consider the diversity in children's cognition in relation to neurotypical and neurodiverse children in the classroom. So we are going to begin with working memory as our first executive function we're going to talk about. So ADHD affects a child's executive functioning, including working memory. So working memory is the ability to keep information in the mind for a short period of time so that it can be actively used and manipulated. This is relevant to cognitive development, as those with attention deficits will experience significant impairments with working memory, which influences their academic performance and success in the classroom. So an example of this in terms of problem-solving ability is a teacher verbally instructs her class to solve a multi-step math problem. So she says add 27 and 14 and subtract 9 from the sum, then multiply the answer by 2. While others begin solving the problem, a student named Carla, who has ADHD, is having a hard time keeping all the steps in her head and actively solving them. She starts adding 27 and 14, but by the time she finishes, she's already forgotten what comes next, and she struggles to mentally work with the verbal information. So let's think about it. What accommodations can be made in the classroom to help children like Carla with ADHD? So, accommodations and Vygotsky. So, understanding that children with ADHD struggle with problem-solving tasks requiring working memory allows teachers to provide accessible options and support during these tasks. So, an example of this could be writing the steps on the board so that a student can refer back to them, giving students with ADHD a checklist to mark off each step as they complete the task, and encouraging students to whisper the problem out loud to themselves to reinforce the memory of the problem. So by providing accommodations like learning strategies to children with ADHD, it allows them to better complete working memory tasks they might otherwise struggle with and become more independent at a pace appropriate to them. So this aligns with Vygotsky's theory of scaffolding and the zone of proximal development, as the teacher provides a temporary support to aid children with ADHD in completing a task they cannot do independently and potentially removing cues as they see fit. So, a study by Fassbender et al. Identified a strong correlation between poor working memory in children with ADHD and a lack of specialization of brain function. So, they found that brain scans of those typically developing and ADHD children during task completion indicated that those with ADHD consistently showed reduced working memory task-specific brain activation in comparison to our control group. So, the typically developing control group showed working memory specific activity in the bilateral prefrontal cortex, while those with ADHD did not. And those with ADHD actually showed hyperactivity in the medial prefrontal cortex during working memory tasks. So the medial prefrontal cortex is associated with the default mode attention network, which is usually inactive during these cognitively demanding tasks. And the inability to suppress this activity is associated with the memory errors and distractibility in ADHD. So the observed hypoactivity and hyperactivity supports the claim that there are working memory deficits in those with ADHD. Given the prefrontal cortex's role in executive functions, it's essential that these children are met with appropriate accommodations in order to limit cognitive deficits during these working memory tasks. So, a real world example. So, as a child growing up with ADHD, I personally felt that I was always falling behind in terms of working memory. An example of this is I could remember a second grade math game that we played. So students had to answer randomized math questions on the spot, and if you got it wrong, you'd sit out for the rest of the game. And I could never solve mental math problems quickly and tended to always be the first one sitting out. These were math problems I could easily solve in homework questions, but when I had to work efficiently with new information and solve it quickly, I always had difficulty. And for this reason, I believe that further research must be done by the school board to recognize struggles and help accommodate neurodiverse children. This fosters an inclusive class environment, allowing all children, no matter their abilities, to feel comfortable and seen, which is essential to a child's overall well-being and development.
All right, so now we're going to move on to inhibitory control. So, inhibitory control is a core executive function that is crucial for cognitive development, especially within a classroom setting. In regards to ADHD, this disorder is often characterized by a lack of inhibitory control. So, research in cognitive development has highlighted how deficits in inhibitory control contribute to ADHD symptoms like inattention, hyperactivity, and impulsivity. This suggests that children with ADHD have more difficulties inhibiting their thoughts, sustaining attention, and controlling their behaviors. So, Barkley's model of executive dysfunction in ADHD further suggests how inhibitory control deficits can impair one's ability to delay gratification, follow instructions, and resist distractions. So, think about it. How can teachers implement strategies to help students with ADHD manage inhibitory control in the classroom? So, number one, we have reducing distractions. So, as children with ADHD struggle with distractibility and inattention, a quiet environment can help them to sustain focus on a task. So, research highlights that seating children in areas away from windows and doors can enhance attention and foster effective task completion. That said, on various attention tasks, children with ADHD do not differ at all from other children. Example, when engaged in preferred activities, children with ADHD often demonstrate similar or even better attention and engagement than their fellow peers. Now we have classroom implementation. So, as children with ADHD's frontal cortex develop slower and their motor regions mature faster, implementing hands on activities like fun experiments alongside verbal and visual demonstrations can help enhance attention and learning quality as they benefit from a multisensory type of learning. Next is providing external supports. So, according to the PREMAC principle, children are more likely to engage in less preferred activities like completing work and assignments when they're followed by a preferred activity like a short break. So, teachers can implement structured body breaks into classroom routines, giving students 4 to 6 minutes to release excess energy. And these breaks can actually help students to maintain focus, increase motivation, and reduce distractions during class time and lessons. This is especially important for students with ADHD as movement can support their ability to manage their hyperactivity. So, a real world example, so studies show that physical activity can help enhance executive functions and increase prefrontal cortex activity, benefiting children, including those with ADHD. When I personally worked in a classroom with 32 children, where many of the students had IEPs and ADHD as well, I found the structuring classroom time with 6 minute body breaks helped students to sustain engagement throughout the lesson without distractions. So next is self-regulation strategies. So Vygotsky's theory highlights how private speech plays a crucial role in developing executive functioning, self-regulation, and impulse control. That said, children with ADHD struggle with private speech internalization, on-task, self-directed speech, and inhibiting irrelevant social speech. These deficits make classroom self-regulation a bit more challenging. So, how can teachers encourage self regulation? So, as we know, a child with ADHD may have difficulty staying on task, talking to peers instead of using self directed speech and focusing on their own tasks. So, to encourage self regulation and speech internalization, teachers can reinforce the stop and think rule, prompting children to pause before speaking. This could be verbally or it could be through visual demonstrations like little stop signs around the classroom, as well as little reminders on their desk. So, next we have positive reinforcement. So, thanking the student for raising their hand and selecting them to answer when they raise their hand can further support this impulse control. This aligns with behavioral theories of development, specifically operant conditioning, where behavior that is rewarded is more likely to be repeated.
Let's finish with cognitive flexibility. Cognitive flexibility is the ability to easily switch and adjust behaviors in between various tasks in your environment in order to generate appropriate behavior responses. In terms of academic success, children of high cognitive flexibility can adapt their learning strategies, engage in critical thinking, and develop into self-independent learners. And children of high cognitive flexibility have also advantages in terms of social and emotional development. However, cognitive flexibility is hindered in children with ADHD, resulting in cognitive inflexibility, which often indicates that they also struggle academically due to difficulties in adapting adapting to various different tasks, organizing their thoughts, as well as shifting their focus between subjects and tasks. Research in cognitive development has highlighted how children with ADHD struggle with cognitive flexibility, such as the Yin and Alice study, which found that children with ADHD had significantly lower cognitive flexibility compared to typically developing children, and they found that lower cognitive flexibility was related to difficulty switching tasks or controlling attention. Marzocchi and Alice study found that children with ADHD performed significantly worse on the Wisconsin card sorting test than studies control group, and the Wisconsin card sorting test is a test to measure cognitive flexibility. And Holmes and Alice study found that children with ADHD have deficits in cognitive flexibility as they perform more poorly than typically developing children on executive functioning tasks such as set shifting. So think about it. How can teachers implement strategies to help students with ADHD manage cognitive flexibility deficits? Well, one way could be to implement a class calendar, daily schedule, and advance notice of change. As per Piaget's theory of cognitive development, every child goes through the same four developmental stages, but does so at a different speed. Teachers should design their classroom to suit every child's developmental needs instead of standardizing their classroom function. Piaget argues that cognitive and intellectual development happens through a process of adaptation, through accommodation and assimilation, where accommodation is where the learner has to adjust their cognitive structure in order to fit and incorporate new learned information, where assimilation is the process in which information that matches and builds on pre-existing knowledge can be readily incorporated into the learner's cognitive structure. However, when children encounter information that conflict with their current knowledge, they experience cognitive disequilibrium, and this disequilibrium is even worse for children with ADHD. So, implementing a class calendar can help students with ADHD be able to visualize, mentally accommodate for the change, and help them adapt more easily, which aligns with Piaget's accommodation and assimilation. And a real-world example of this is when I substitute taught a class, the teacher had a large poster board displaying the daily schedule. I noticed students frequently checked it. The teacher explained that since implementing the calendar, students adapted more easily to transitions, felt more prepared, and were able to ask questions in advance, reducing confusion and stress, and increasing the ability to adapt to change in the schedule easier. Another accommodation could be incorporating at least 30 minutes of daily physical activity with various aerobic exercises to enhance cognitive flexibility. And a study in 2009 wanted to investigate if aerobic exercise improves various domains of cognition, such as cognitive flexibility. And the study concluded that increasing frequency of aerobic activity was shown to be significantly associated with enhanced cognitive performance in various cognitive domains, in particular cognitive flexibility. Yang and al. study found that aerobic exercise can enhance the executive functions activity of ADHD children, and given that children with ADHD are challenged in many academic situations, short aerobic exercise is recommended to allow optimal performance in situations that require cognitive flexibility. As previously mentioned, children with ADHD have distinct strengths and challenges in cognitive skills that impact their learning. Specifically, they experience difficulties in executive functions, which include working memory, inhibitory control, and cognitive flexibility. Using the information presented in this presentation, practical accommodations could be used to create more enriching learning environments with students struggling with ADHD. Furthermore, they also provide information to aid teachers in creating a more inclusive learning environment for each individual needs of their students. For example, helping children with ADHD who have deficits in working memory could be providing students with learning strategies and accommodations based on Vygotsky's zone of proximal development. Helping children with ADHD who have deficits in cognitive inhibition could be reducing distractions by sitting child in a quiet area of classroom. And finally, helping children with ADHD in reducing deficits in cognitive flexibility would be implementing a class calendar with advanced notices of changes in classroom events based on Piaget's adaptation through accommodation and assimilation. Thank you so much for listening to our presentation.